Look at all these things. What do you think they have in common? If you said they're all types of magnets, then we're thinking the same thing.
Magnets are types of rock or metal that can either be found in nature or made by people. All magnets have invisible powers.
These powers make magnets stick to things and pull other magnets closer. Magnets can also push other magnets away.
These pushes and pulls are called magnetism, and they happen in an area around the magnet called a magnetic field. Magnetism is a big reason why magnets can do so many incredible things.
Hi, I'm Mackenzie. Today we're going to learn all about the powers of magnets at one of the most magnetic places on Earth.
I'm Daniel. We are hosts for a very special virtual field trip to the U.S. National Science Foundation's National High Magnetic Field Laboratory. Whew, that was a long name. We'll just call it the Mag Lab. The Mag Lab is located in 3 places in the United States. We will be going behind the scenes to the Mag Lab in Tallahassee, Florida, home to some of the most powerful magnets in the world.
Come along as we explore this amazing place. Meet scientists and lots of other people who use these magnets to answer big questions and learn why magnets are such an important part of our lives. Let's get ready to meet the magnets!
Our first stop is the Magnet Factory, the place where almost all the Mag Lab's magnets are made.
Hi, Tim.
Hi, Daniel. Hi, Mackenzie. Welcome to the Magnet Factory.
Tim, what do you do here at the Mag Lab?
I am a scientist here at the Mag Lab. So are you familiar with what a scientist's job is?
No.
One of the things that scientists do is we start with the question of why. So why is this table solid? Why, when I push on here, why doesn't my hand just go right through it? When we do experiments in high magnetic fields, that is helping us answer questions like that.
What kind of magnets do you make here?
We make magnets that are called electromagnets. Those are magnets that when we put an electric current through them, they generate a magnetic field in the center. You may be familiar with magnets that you have at home, which are called permanent magnets, like on your refrigerator.
Yes.
So an example of a permanent magnet is a horseshoe magnet.
Whoa.
Have you guys ever used a horseshoe magnet before?
I don't think so, no.
So see how it attracts itself to a piece of steel,
Wow.
right? So you're generating a force. So go ahead and pull it on.
It's perfect.
Okay. There's another type of magnet. It's called a rare earth magnet. So what we could do, magnetic fields can penetrate all sorts of things. So those are the two fields of the two magnets interacting.
Whoa. Why does the Mag Lab make electromagnets?
That's a great question, Daniel. A magnetic field allows scientists to see what's going on inside a material. And the higher the magnetic field, the better we can see.
What do electromagnets need to work?
Electromagnets need 2 things. They're going to need electricity and they're going to need a conductor. So the electricity is supplied from a giant power supply. Are you guys familiar with electric current?
No, we're not shy.
Have you ever plugged something into the wall socket at home, like a lamp or something else, or a TV?
Yeah.
So when you do that, you're drawing current from the wires in your house, and that current is flowing through the device, which makes light, right? Like the lights in the ceiling. So what we do is we use this conductor, we bring in that electric current, and it goes around and around and around. By doing that, it produces a magnetic field that's right here in the center. The scientists come to the Mag Lab, they put their experiments right at the center of the magnetic field where it's highest. So then they can see further and better into the material than you can at lower fields or even no magnetic field.
So, how do you build a magnet?
What we need to do is we need to build a coil for the electric current to run around in, like what you see here. So the way we do it is we take plates of metal and we stack them up. And each of those plates of metal is a turn, and that makes our coil. As the electric current flows through that coil, it generates a magnetic field in the center. And that's how we build our magnet. Would you guys like to help us build a magnet?
Yeah.
All right, Daniel and Mackenzie, this is how you build an electromagnet. You take this part, slide it down the rods. Now, Mackenzie, you take this part, you slide it down the rods. And we go round and round like a spiral staircase.
Wow.
Are you a scientist?
I'm not a scientist, I'm a magnet technician. My job is to build electromagnets.
How many discs does it take to make a whole electromagnet?
Well, it varies from magnet to magnet, but this particular electromagnet takes 960 discs.
Wow, so we're not even halfway there.
We are not halfway there.
While Daniel and I work on this magnet, let's learn more about why magnets matter in our lives. Think about all the things in our world that make our lives better. Would you believe that many of them exist because of magnets? We use magnets in our homes. From simple refrigerator magnets that hold things to games that let us build and create. We use magnets every time we turn on a television, computer, or listen to music. We use them when we go for a drive, open doors, and pay for things we need. Nurses, doctors, and other medical experts use them to look inside our bodies and help us stay healthy. These are just a few of the many reasons to thank magnets throughout our day. Humans have known about magnets for a very long time. More than 2,500 years. That's over 25 centuries. We first discovered magnets in stones. People saw that certain stones pulled or attracted other stones in iron to them. These stones were discovered in China and parts of Europe. In English, they're called lodestones. They're known as permanent magnets because they're always magnetic. Early explorers used lodestones to create the first compass. A compass is a tool that helps explorers find the direction of north, making it possible to travel across land or sea and still find your way back. At the Mag Lab, the magnets are temporary magnets, meaning they're only magnetic some of the time. They're also called electromagnets because they need electricity to work. Scientists are still studying the science of magnets, with many more mysteries to solve. But here's one thing we know for sure. Without magnets, our lives would be very different than they are today. After finishing our work in the magnet factory, we moved to the DC field building.
DC stands for direct current. It's a type of electricity that flows continuously in one direction. Something the Mag Lab needs to create a steady magnetic field to operate its magnets. We make our next stop in the control room.
The control room is where people make sure the magnets are getting enough direct current electricity, as well as water or other liquids to keep them cool. The rest of the DC field building is made of magnet cells. Each holds a different type of magnet. Many of them the most powerful of their kind in the world.
Cell 5 goes to 25 Tesla, Cell 9 to 31 Tesla, and Cell 15 all the way up to 45 Tesla, which is the strongest continuous magnetic field found anywhere on Earth.
What do you think Tesla means? And what do you think it has to do with magnets?
I'm glad you asked, Mackenzie. First, let's explore what makes a magnet, and then let's learn how Teslas help us measure how strong they are. already learned that magnets are pieces of rock or metal with invisible powers, and that there are many kinds of them. But do you know what all magnets have in common? All magnets have a north pole and a south pole, just like Earth does. If you try to bring the opposite poles of a magnet together, north to south or south to north, they will attract or pull each other closer. But if you try to bring the same poles of a magnet together, north to north or south to south, they will repel or push each other away. Just as we use inches and centimeters to measure how long something is, scientists measure the strength of magnets using a unit called a Tesla. The name Tesla comes from this guy, Nikola Tesla, a famous inventor who developed a system for generating electricity using rotating magnetic fields. The Earth's magnetic field, which is strong enough to move a compass needle, is just a tiny bit of a Tesla, 0.00005 Tesla. A refrigerator magnet is also less than a Tesla, 0.01 Tesla. A junkyard magnet is about 1 Tesla. An MRI machine that hospitals use to look inside our bodies is between 1.5 to 3 Tesla. Among the dozens of magnets at the Mag Lab, most are more than 10 Tesla strong. The very strongest one goes all the way up to 45 Tesla. Let's meet that magnet now!
Hi, Julia.
Hi, Mackenzie. Hi, Danielle. Welcome to the 45T.
So, where's the magnet?
Would you like to take a guess? What do you think?
Okay, I have 3 guesses. That big one over there, that one that looks like it's in a cage, and the one next to it.
Okay, so actually all of this is part of the magnet system, but the magnet is located in that big cylindrical barrel up there.
Oh.
Why does the 45T have to be on 2 different levels?
Right, that's a really good question. It's actually not easy to make 45 Tesla, and it takes a lot of equipment to do that. So just to fit it all in space, it was put on 2 levels. The magnet is upstairs, and we do experiments from the top. And at the bottom, we have all the stuff that we need to keep the magnet cold and make the magnetic field happen.
Can we go upstairs?
Yes, let's do it.
So where's the magnet?
So we're at the very top right now, and the magnet is right over there.
Why is this here?
This line over here is here so that when the magnet is on, it reminds us not to take anything to the other side that could be pulled in by the magnet. What do you notice about this chair over here?
It's wooden.
It's wood, very good. And do you have any idea why we would have a wooden chair up here?
So the magnet doesn't pull it.
Straight on. All right, the field is off, so we can move the barrier and take a look. All right, right now we are on the top of the 45 Tesla magnet. You guys are sitting on top of the world's strongest steady magnetic field magnet. And if you look inside, you will see this hole at the center, and that is in the very middle of it where we have a very, very strong field, and that is where our experiments take place. So all the 45 Tesla, all this equipment around here is to produce a field at the very center of this tube. So when our scientists come here and bring a material that they have questions about and want to study with the magnetic field, they use a probe like this. Probe is really just a fancy word for a scientific stick. We put our sample on, we use the probe, and we put it in the magnet to bring our experiment to the very center of that field.
What got you interested in magnets? Why did you decide to come work here?
So I'm a scientist, but I'm a scientist actually interested in the instruments and building equipment. And a mag lab like this one is a very fun place to work if you like to build big equipment, because we are sitting on top of the world's strongest steady magnetic field magnet. And I get to play with this type of equipment every day.
Daniel and I split up so we can see more of the Mag Lab. Daniel heads to a type of magnet that you can ride on, while I go to the place where magnets are used to look inside things and figure out what they're made of. Hi, Faye.
Hi, Mackenzie.
So, what magnets are in this part of the Mag Lab?
So in this part of the NSF Mag Lab, we have magnets that are close to what an MRI machine would be at the doctor's office. An MRI machine is something that doctors and nurses use to look inside the body, see organs and stuff like that. But we're looking at a much smaller scale, and we can see things even smaller than you could see with a microscope. And our samples get even smaller too. So these are some of our smallest samples, like that. And then do you want to look at this one too?
Yeah. Oh my gosh, this one's so small. What are these?
So these are probes. These are what we put into the magnet in order to find out more about the sample. We actually built these here at the NSF Mag Lab.
How do you put them into the magnet?
We put the sample in first, and then we take it and load it from the bottom so that the sample is in the center of the magnetic field. The center of the magnetic field is the strongest part, and in the strongest magnetic field, we can get the most information back from the sample.
Do you have a favorite magnet?
Yes, one of my favorite magnets is that one right over there. It's the world's most powerful MRI. It's 21 Tesla. And in a hospital, an MRI is probably going to be about 1.5 Tesla, maybe 3 Tesla. So that's like 7 times stronger than a normal MRI.
What do things look like when you put it in that magnet?
So I've got some images of vegetables that were taken inside that MRI. Do you want to play a game and figure out what they are?
Yes.
All right. So this is our first one.
Ooh. It looks like a snake, but these are vegetables,
These are
right?
vegetables.
These are vegetables.
It grows
Okay.
under the ground.
Under the ground. It has a lot of layers.
It does. You can see them over there.
I'm gonna have to say an onion.
You're right.
Yes.
Okay. So,
Ooh. Does this one go under the ground?
yes.
This is really hard.
What's really good is French fries.
A potato.
Yes. All right.
Ooh, this one has seeds. I can see a
Yes.
seed
So we're finally above ground.
above ground. Okay. What color is this one?
It's red.
A tomato.
Tomato. Yes. Okay, now this is the trickiest one of all.
Ooh. Above ground or underground?
So this is above ground.
Above
Grows out of the ground.
Okay. Does it have layers or is it just one
It's just one layer. It goes
One
up
layer.
straight,
straight?
and it's green.
Green. What does it start with?
It starts with A.
A. Asparagus.
Asparagus. Yes, you got them all. Good job.
While Mackenzie is with Faith, I get a chance to ride the Human Levitator. It's a special platform with one magnet that levitates or floats above another magnet. What is making the magnet levitate?
So we have 2 giant magnets here, just like these in my hand. So you know how the opposites attract, pull together? Well, the same sides push apart, just like this. Do you want to try it?
Yeah.
So this is a small version of what's going to be happening here.
So what's that smoky stuff coming out of it?
So this is a thing called liquid nitrogen. It's what keeps these magnets cold enough to do the levitation.
So can I ride it?
Yeah, let's go ahead. But to be safe, I want to make sure you have 2 hands on the rail as you're getting on. So step up on there with both hands on the railing, 1 foot at a time. And once you feel comfortable, you can go ahead and start spinning.
I think I might start spinning now. Whew.
How does it feel?
Feels like I'm floating on air.
Yeah, it's a magnetic cushion of air between 2 magnets.
While I take a few more spins on this human levitator, let's learn more about why the National Science Foundation built the Mag Lab.
The U.S. National Science Foundation is in the business of exploring the future. We help researchers from around the country and even around the world explore and discover the things that will be in our everyday life 10, 20, 30 years from now. Hi, I'm Germano Yannikiani. I'm a division director at the U.S. National Science Foundation. The National Science Foundation built the Mag Lab so that people can ask and answer the big questions about magnetic fields, how they are, and how they can be used.
Hi, I'm Dr. Kathleen Am. I'm the director of the NSF, National High Magnetic Field Laboratory. The NSF Mag Lab has the highest strength magnets in the world and also some of the most advanced scientific techniques to measure materials in magnetic fields. And so it's an incredibly important place for scientists from around the world to come and study at the cutting edge of research.
The NSF Mag Lab holds an open house every year that is available to anyone who's here. And this is important because one of the things about science that is so critical, so important, is that we need to share with everybody what we do here.
Everybody is allowed to come to the NSF Mag Lab. It's a special place. It's owned by all of us, and you're very welcome to come, and I hope to see you there.
Our time at the Mag Lab is winding down. Let's have a little fun and make an electromagnet of our own.
Hi, Mackenzie. Hi, Daniel.
Hi, Charmaine. So, what do you do here at the Mag Lab?
I'm a scientist here at NSF Mag Lab. I support other scientists who do measurements in high magnetic fields. Today, what we're going to do actually is make our own little electromagnet. As you remember from your earlier time around the Magnet Lab, this right here is an example magnet. It's basically a coil of copper wire that conducts electricity all the way around in a spiral. When electricity flows through this, a magnetic field is created in the middle of this coil. So what we'll do is actually build our own little coil here, as you can see as an example. Here's another example.
To do this experiment, we need some electrical wire, an iron nail, a few paper clips, a common battery, these are D batteries, and a battery holder.
While this experiment can be done at home or school, always make sure a grown-up is there to help you.
So what we need to do is first take our iron nail. You have one.
Thank you.
You're welcome. And then we're also going to use electrical wire. Grab this one. And now what we're going to do is make a coil like this. Okay, so we're going to wrap this electrical wire around this nail 10 times.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to try to make it somewhat as smooth as this. Nice. So now you have your own little electromagnet, right? And it looks basically like this if you turn it sideways, right? It's basically a spiral.
Yeah.
But the only extra thing now we have is an iron nail. This iron nail will help us focus the magnetic field. Okay, so first we're going to prove that what we've made is not magnetic first, right? So let's try this. See, non-magnetic, all right? So now we're going to magnetize it. And to do this, now we're going to connect that power source. Before you do it, let me just show you. If you squeeze the sides of this, you can see a little opening to put your wire in. All right? So if you I'll show you here. If I squeeze like this, the wire goes like that. Now just let go. Check. Perfect. Check this one. Perfect. All right. So now we're going to the next side. Squeeze. And once you have it in there, just let it go for a second. All right, awesome. So now hold a paper clip in your hand. And this time hold the battery like this and see if your electromagnet now works. Mine works. What? Daniel's work. Awesome. Yeah. And that's it. And that's your electromagnet.
Wow, we've met so many magnets during our virtual field trip.
We hope you've had a good time at the Mag Lab and learned lots about why magnets are so important to our lives.
Thank you to all the amazing scientists and other people who showed us around the Mag Lab.
And thank you to all the magnificent magnets we got to meet that made our trip so fun.
Don't forget, the Mag Lab belongs to all of us.
So if you're ever in Tallahassee, Florida, stop by and meet the magnets yourself. Bye.